Hi guys, and welcome to today's lesson on 7.2. We're going to be talking about scientific notation. So our objective today, be able to write in scientific and standard notation. Central question, what is the difference between scientific and standard notation? Like always, if you feel the need to pause the video, feel free to do so, and I'll get moving forward here. So to begin with, scientific notation, a number in scientific notation is written as the product of two factors in this form. So it's always going to look just like this. A times 10 to the n power. This part's where n is an integer, and then 1 is less than or equal to a, which is less than 10. So what that's really saying is it's a single digit integer, but it also could then be decimals there as well. But a number that's less or greater than or equal to 1, but less than 10. So we have some examples there, like 8.3 times 10 to the fifth, 7.1 times 10 to the negative fifth. Notice you can have positive and negative. So our first question here says, which of these is not written in proper scientific notation? So what we want to focus on is first our a values. So if we look at these a values, we need to check to see, are they greater than or equal to 1 and less than 10? If we look at A, that's true. We look at C as well, that one's true. But now notice if we look at B, 12.9 is not less than 10. And so this one right here, I guess that's technically our answer. So we'll go back. This one right here is the one that is not written in proper scientific notation. So real quick, sometimes in our calculator we're going to get some a funky looking symbol like this or an answer like this. And so I want to make sure we understand what this means. If it says like 3.15 E12, that E is saying the exponent is, and then it's whatever number that's there. So what this is really telling us is we have 3.15 times 10 to the 12th power. So again, if you ever see that on your calculator, that's what it's saying. Times 10 to the whatever power that x or that value is. Real quick, if you'd like to pause it on here, you're welcome to. This is just going through a couple examples of what scientific notation looks like. Key thing I want us just to notice here, right, those positive values, right, positive exponents here. Positive exponents equal bigger numbers. Now notice our negative exponents here, these numbers are quite smaller. So negative exponents give us smaller numbers. So that's a key thing to think about here. So if you want to pause it, feel free to. If not, I'm going to get moving forward here. So first example, write each number in scientific notation. So what we need to focus on is we need to get our A value, right? And we talked about that already earlier here today, that it has to be between 1 and 10. It can be greater than or equal to 1, but it must be less than 10. So what we're going to do is we're going to focus on this value here and find where we can get a single digit number. Might have some decimal after it, that's fine. But if we look at population of Florida, I'm going to put my decimal point right here. Notice my A value is now going to be 2.1. What I want to focus on now is what we're really asking ourselves in scientific notation is how far do I have to move that decimal point? So if I'm at 2.1, to get to my 21 million, I'm going to have to move it 1, 2, hold on one sec. Move it 1, 2, 3, 4, 5, 6, 7 spots. So what this means is we're taking times 10 to the 7th power. Notice I moved to the right 7, so that's where I get 7, and it's positive. So right, that's an example of where our exponent is positive. Now let's look at this one. So now diameter of an atom, right? It's 0.00000000002. So I'm going to move my decimal point to here so I get a number that is greater than or equal to 1, but less than 10. So I have 2 times 10 to the, and now we need to figure out, if I have my decimal point here, how do I get back to my original problem? Well, I have to go back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Notice this time, though, I went to the left 10. So that means my exponent is going to be a negative value. So key thing to notice, positive values mean that I move my decimal place to the right. Negative values means I'm moving my decimal place to the left. So now what we're going to do is work backwards, right? Write each number in standard notation. So I always start by writing out your A. So my A is 2.8, but now notice I have times 10 to the positive 6. Positive tells you right away I'm moving it 1, 2, 3, 4, 5, 6 spots. And since it's positive, that means to the right. Wherever there's an open spot, you're always going to fill that in with a 0. So in this case, the truck weighs 2,800,000 grams. So now let's try the same thing, but with a negative exponent. So I have a 2 here, and the decimal point is right here. But now with a negative exponent, that means I'm going 1, 2, 3 spots to the left. And again, just like up above, fill in those missing pieces with a 0. So my answer for this one is the paper clip weighs 0.002 pounds. So those are my 2 answers there. So again, if you need to pause it, feel free to do so. 2 examples here real quick. If you'd like to pause them, try them real quick, but I'm going to go over those answers right now. So if I have 1.6 times 10 to the 4th, that means I'm taking 1.6, moving that decimal place 1, 2, 3, 4 spots to the right for an answer of 16,000. Same thing here, but now with 2, and then now moving it to the left, 1, 2, 3, 4, 5. So I have an answer of 0.00002. And those should be your answers for those 2. So moving forward, this kind of is like a level 4 problem, a little tricky here, but we're going to talk through it. So rewriting numbers, they might look really similar to scientific notation, but not quite. What I want us to do in this case is always write out the answer first, then we'll rewrite it. So we're going to write it out first in standard notation, and then we'll write it in actual scientific notation. Because notice these A values are not greater than 1 and less than 10. So what I'm going to do is, if I rewrite this, my decimal point is here. My answer, moving this 1, 2, 3, 4, 5, 6, 7 spots, would give me an answer of 0.00054336. Well now, right, I want this in scientific notation, so that means I want my decimal point to be right here. So it's going to be 5.436, but to move from here to there, I have to go to the left 1, 2, 3, 4. So times 10 to the negative 4th. So write it out in standard notation first, then work backwards. So same thing here. I'm now first going to times by 10 to the 3rd, so that means I move it 1, 2, 3 spots. So really I have 0.456, but I know I need my decimal point to be right here. So I'm going to have 5.46, and to get back to that green one, I got to move to the left 1. So it'll be times 10 to the negative 1st. Awesome. So last part is writing in order from least to greatest. Just like those problems we did above, I want us to put it in standard form first. I think it's the nicest way to do it, and then we can compare those values. So I'm just going to rewrite all these in standard form. you want to pause it and try it yourself first, I'm going to go through all 4 of these. So -3 tells us 1, 2, 3 spots to the left. So in standard form, I get this. +3 tells me 1, 2, 3 spots to the right. So that's that one. This is 2 spots to the right. And this is 2 spots to the left. And so in standard form, these are my 4 answers. So if I'm asked to order from least to greatest, right, least would be the smallest one here. So that would be this one right here. Now as I'm getting larger, right, it'd be this one down here, followed by this one. And then this is our greatest of the 4 values. So that is it for today's lesson on 7.2, talking about scientific notation.